Alright, let's spend a little bit more time talking about these numbers. Specifically, we're talking about prime numbers now. Prime numbers are numbers that only have two factors. How many numbers do prime numbers have? Two. How many factors do prime numbers have? Alright, so prime factors. Well, actually, yeah, let's talk about prime numbers first. I don't know why I jumped down here. So prime numbers are numbers that can't be broken up, essentially. So 2 is the first example of a prime number. The factors of 2... the factors of 2 are 1 and 2. There's nothing else that divides evenly into 2. You can see we're already bigger than 2 if we get any farther than that. 3 is also a prime number. 1 goes into it, and 3 goes into it. Another way of saying this is the only way to write a prime number as a product of two whole numbers is by taking 1 times the whole number, whatever number you're talking about. 4, if you're looking to see if 4 is a prime number, well, 4 could be written as 1 times 4, but it could also be written as 2 times 2. So 4 is not an example of a prime number. 5 is an example of a prime number, so the only factors of 5 are 1 and 5. And we could go through this list a little bit further. 6 is not prime, but 7 is. 8, 9, 10, those are not prime. 8 is divisible by 2, 9 is divisible by 3, 10 is divisible by 2. But 11 is prime. Then the next prime number would be 13. And you'll notice that all the prime numbers other than 2 are going to be odd. Let's think about why that is. If we had a prime number that's divisible by 2, then it's divisible by 2. But the only way it can be prime is if it's not divisible by anything other than 1 or itself. So, 2 is the only prime number that's divisible by 2, just like 3 is the only prime number that's divisible by 3. The only reason it kind of stands out with even numbers is we notice even numbers a lot because they're pretty easy to spot. You can actually say the same thing about numbers that are divisible by 5, but we don't have special language for numbers that are divisible by 5. 10's not prime, 15's not prime, 20 is not prime. None of those are prime because they're divisible by 5. All right, so if you're looking through these prime numbers, you can actually start skipping things. You can say, okay, well, 15 isn't, I'm kind of looking at the next odd number. 15's not prime. 17, I would want to go through and actually verify it, but 17 is a prime number. 19 is a prime number, and you can keep this up. There are methods out there for finding the first so many prime numbers. I recommend just having a list of the first few prime numbers and using that when you're trying to figure out when you're trying to deal with these prime numbers. All right, so how many factors do prime numbers have? They only have 2 factors, 1 and themselves. Let's list the prime factors of 14. We already listed the factors of 14, 1, 2, 7, and 14. This is from a previous video. So all we need to do is to figure out the prime factors, we need to look through these and say, okay, which of these are prime numbers? Well, let's see, 14 is clearly not a prime number because it could be written as 2 times 7 or 1 times 14. So it's not prime. Also, it has 4 factors. Now, the question then remains, what about 1? You'll notice I just kind of conveniently skipped past 1 up there. We actually say that 1 is not prime either, because it only has 1 factor. The reasons for why we exclude 1 from the list of prime factors, it's a bit beyond the scope of this course, but really it comes down to the fact that when we have the prime factors of a number, we can do what's called a prime factorization. And the prime factorization of a number is writing a number as a product of all its primes. In this case, the prime factorization of 14 is 2 times 7. It's a product of several prime numbers. The nice thing about a prime factorization of a number is that there's only one way to do it. Other than rearranging this, I could say 7 times 2. But there's only one prime factorization of a number. And if we allowed 1s to be a prime number, that we would have to have all sorts of, additional statements saying, oh, we exclude 1s from this definition. So kind of they don't fit very well because of that sort of thing. All right, so let's list the prime factors of 54. Let's see, 1, 2, 3, 4 and 5 weren't. 6, 9, what did we have? 18, 27, and 54, I believe. Let me double check. I'm just scrolling back to where we went over that. 54, 1, 3, 9, 6, 1, 3, 9, 1, 2, 3, 6, 9. Yeah, okay. 1, 2, 3, 6, 9. Okay, looks like we have the same list. If I'm looking through this list and trying to figure out which ones of these are prime, well, I could just look at my list of primes. 2 is a prime number, 3 is a prime number. And it looks like none of those other numbers are on my list of primes. So the prime factors of 54 are 2 and 3. Now, if we wanted to list the prime factorization, we're going to have to include these multiple times. And so to find the prime factorization, I mean, this can be broken down as 2s and 3s. These are the only things that are going to be multiplied together, but there's going to be repeats. So what I'm going to do is I'm going to look at one of these. Let's see, what was it? 6 times 9? Yeah, 54 is 6 times 9. I'm doing what's called a factor tree. So 54 is 6 times 9. I can break each of these down until I get to just prime numbers. And so I ended up with 1 factor of 2 and 3 factors of 3. So 54 is 2 times 3 times 3 times 3. The only prime factors of it are 2 and 3. You can see its prime factorization actually exists, consists of 3 different 3's in there. All right. Yeah. We'll talk more about prime factorizations, especially once we get into fractions. They become important.